Bismillahirrahmanirrahim. Welcome back to the Boltzmann averaging video. So this is just a continuation of the previous video. We ran out of time, so I'm just making this video again. So where were we? Like we were looking like we that this file is obtained from running the script of Boltzmann averaging. So now what we need to do is we can just copy this, the contents of this file. I kept a sheet here to keep a copy of all this NMR data as well. And yeah, we can actually copy it. So if I simply copy all of it, and then I can paste it right here. So now we will have everything in one file. We don't really need to keep the other files. So this is good for record keeping, and I'll just do a little bit of formatting here. So this sheet had a capacity of so many atoms. I'll just delete the extra. So our molecule has only 20 atoms, and I will just, yeah, put some borders around it to make it look similar. And the number of conformers. So now this data you got is basically not basically conformers arranged in the order of their relative energy. And I'll just make it look to, yeah, two decimal places. And then you see that we've got everything. And at the bottom, we got the atom numbers, atom symbols, and Boltzmann averaged shielding tensors. Like this shielding tensor is averaged according to Boltzmann distribution. So now I have another sheet called scaled NMR data. What it is, I will just copy the data here first, and then tell you what to do next with it. So I'll just copy these three things. Copy, come to this sheet, and then paste here. How will I paste it? Because it was horizontal and I want to paste it vertical. So I'll just use this option transpose, right click and transpose, so it will paste it this way. So now we got this data here, and this sheet is basically for a bigger molecule, but I just want to show you the concept. So you can, yeah, you can use it later on. And what will we do is I will just copy this data here. We don't really need this bit, and I will copy this and paste it here and delete the extra data at the moment. So yeah, I kept this whole sheet so you can easily use it, and we'll delete the experimental carbon number because that's what we need to do right now. So forget about the experimental data at the moment. It's for a bigger molecule, but you can put your experimental data like this. If your carbon number 1 is a CH2, you put it here, and then you leave two places for the HNMR. And this sheet is to compare the computed NMR. So this is the experimental NMR. And what happens now is you just open your molecule, for example, any conformer in Gauss view, and then you have your molecule, and you can look at the labels. And now you come here, you see that carbon number 1 computationally is this carbon, but what it is in here, for example, the experimental thing was like we start numbering from here. This is carbon number 1, 2, and then 3, 4, 5. That's how it was experimentally when you ran the NMR. So now what will we do is carbon number 5 is basically carbon number 1 in the experiment. So we will look for carbon number 5 and just put 1 here. So yeah, I'm just keeping 1 here so that I can link it to this sheet. So this sheet is basically linked to the numbers in the other sheet you can see. So what I will do is, So this is carbon number 1. I will just say equals, this is carbon 1, and link here, click here, and then press enter. So it will take data from here now. And what I've done here is put the formulas. I'll show you about in a minute. And so this is carbon number 2. Number 4 is carbon number 2. You can put here. So this will just be your memory, like which carbon related to which carbon. And then 15 and 16 number hydrogens, these two, they are attached to carbon number 2. So I'll just keep 2. So and then later on, why I'm doing this, I can arrange this sheet according to this column and then easily compare with the experiment and copy the data anywhere else if it's a bigger molecule. Otherwise, you don't really need to do this. You can simply uh, link these carbons, like these ones, values directly here like this. You see, this is M7. If you want to change it, you can change it to anyone, and then it will take data from there. So this is your final sheet. And now, here are the formulas, and these formulas were taken. I just put the CHESHIRE NMR repository thing here in my Excel sheet to keep like in my mind, like where did I take the data from? So I use these slopes and intercept values for carbon and hydrogens. So for carbon, it is the formula is like this, and so it is basically using the value of, was it intercept? Yeah, minus the shielding tensor and then divided by minus slope. So that is what is here, and the value of slope was already minus, so I didn't put another minus because minus minus becomes plus here, and that's how the formula looks like. So, and that for hydrogen, you will see the formula is different. So this was for hydrogen. I just copied the data for into a different sheet, so it looks like this. But you will use this formula for hydrogen and this formula for carbon, and you can put it in your Excel sheet, and then you get this data from here, which you can compare to the experimental data. And now you can, I have another sheet where we compare everything. So what I do is I just copy this whole thing and paste it here. And here now I've got the experimental data and computational data. And now I can calculate the delta del value. So what it is basically chemical shift of the computed data minus the experimental data, and it gives me the difference, delta del. And this is for carbon NMR, this is for hydrogen NMR. And then I can calculate their mean absolute error here at the bottom, and then RMS, root mean square error for the NMR data for both hydrogen and carbon NMR. And yeah, this sheet is basically giving you the final table which you can use in the publication. So you can use in the publication this table and tell about the delta del values, and then you can also give the mean absolute error in our RMSE just as a final number. You don't really need to put a whole of this thing in the paper. You can put it in the supporting information, but that is the procedure you use to compare the NMR values of a molecule. And yeah, so it is a bit of work. It's not like everything is not completely automatic. So you have to look for especially the atomic numbers and adjust them according to your experimental atomic numbers, because you know experimentally we number the carbons and then we don't number the hydrogens. So hydrogen is like if it is carbon number 1 or 2, hydrogen will be H2. But computationally, we have a number for each atom. So we just have to put the right data here. So how will you behave with the CH3s? So basically, you will take this atom number 18, 19, and 20, and you take an average of all three, and you use these values for hydrogen NMR. So that was all about doing a complete conformational analysis, NMR, data, everything. And I hope you would have got the main point, and you, with a little bit of practice, you can learn it. but it might be a bit challenging at start, but when you practice it, you watch the video and you follow the steps, I hope you will be good at comparing the NMR for conformationally flexible molecules. And if you still got any questions, you can contact me. You can put a comment in the video, and then I've also made a website which I'm trying to update as soon as I have some time, and it will have all the information about computational chemistry, different errors and their solutions, etc. So you can visit the website, which is in the description. And yeah, so I'll see you in some next video. Thank you very much for watching. Bye bye.